Okay, this is one of those that has been giving you guys a lot of trouble. But again, inverse, for to solve the equation, you're going to switch the x and the y. So we have to recognize who's the x and the y. And this guy, g of x, happens to be your y. And this x happens to be your x. So to find the inverse equation, our first step is to switch x and y. So wherever I see the y, I'm going to change it to an x. Wherever I see the x, I'm going to change it to y. And then I'm going to solve for y. And when you do that, when you're actually solving for y, or you're ready to solve for y, then you are undoing. You are solving for y, you're undoing. So you have to go backwards here. You have to do the addition and subtraction first. So if I look at this equation here, I'm trying to leave the y by itself, but this is multiplying, so I cannot mess with this. I got to do all the adding and subtracting first. This is adding with this. So here I can do the opposite of minus 4. I can add 4. And I have x plus 4 over here equal to 5/3. Why? I just bring this down, right? There's no more adding and subtracting to leave the y by itself, but there is multiplying and dividing. So now I move to that. I can see here I'm multiplying by 5, dividing by 3. So I'm going to get rid of the bottom number first. Okay, but again, you multiply everything times 3. So that means that x and 4 get multiplied by 3. Over here, these 3's cancel, leaving you 5y. And now you can finally just, the opposite or the inverse of multiplying would be dividing. So I can divide everything by 5, the 3 and the 12. The final answer would be y equals, okay, here's my y right here, and it equals all of that, which is 3/5 x plus 12/5. And if you indicate it with a -1 power, that means that you found the inverse. So you would either see it like this or like this. So that's also an answer. Also notice that your 5's are the same. So if you don't see this answer, it's probably because they wrote it as a common denominator. In other words, you can write it like this also. So either one of those, okay? Either one of these two.